Okay, so the other videos that you were just watching were recycled from my stats class for how to do linear regressions and what the R values and everything means. So adding on to that are exponential and other types of regressions. Procedurally, there is nothing different between doing an exponential regression, a natural log regression, a linear regression, any of the regressions. Procedurally, they're all the same. It's just a matter of what function you're going to use in your calculator to get the answer that you're looking for. Okay? So here's an example for exponential regression. All right, let X be the years and age of a licensed driver and Y be the percent of fatal accidents for an age given age due to speeding. So we're going to solve for R. We're not going to do a linear regression. We're going to do an exponential regression for this. And then we're going to determine the ages of a driver responsible for half of all accidents and for somebody who's 90 years old. Okay? So just as we did for all the other ones, we're going to type our data in for X and Y into lists 1 and 2 respectively. So we've got 17, 27, 37, 47, 57, 67, and 77. I just like to go back up and make sure all of my numbers mesh, and we're good. 36, 25, 20, 12, 10, 7, and 5, and then we have 77 and 55, 67 and 7, 57 and 10, 12 and 47, 20 and 37. Yep, so everybody's lined up nicely. All right. So stat, calc, like we were doing before. And now we're looking for an exponential regression. So we're going to scroll down to, in my calculator, it's option 0, exponential regression. It's going to ask me for list 1 and list 2 and to store everything. I'm just going to go down to calculate. So my sample correlation coefficient, R, is negative 0.997. I'm rounding everything to 3 decimal places. So there's A. There's B. Y equals 62.138 times 0.968 raised to the X value. So there's our regression. All right, so remember, X is age, Y is percent. So now for part C, it says 50%, which means that's our Y value. So 50%, 62.138 times 0.968 raised to the X. Now, in order to solve for X here, we're going to need to use logs because we're solving for an exponent. And there's other ways to do this as well. I'll show you in a minute. But if we want any type of accuracy, we're going to have to do it by hand. So we're going to divide by 62.138. So 0.805 equals 0.968 to the X. Now to get this the way we want it, we're going to do the natural log of 0.805 equals the natural log of 0.968 raised to the X. And our rules of logs, let the X go in front. And then we divide by the natural log So x ends up being about 6.68 years. All right. Another way to do it is that if you notice between 57 and 67 years of age, I'm sorry, I'm way off here. I'm confusing my X's and Y's. A 17-year-old is responsible for 17-year-old is responsible for 36% of all accidents. Whoever it is has to be younger than 17. So you could just start plugging numbers in. We'll say this person's 7 years old. So you could just start plugging values in for X and work it backwards. So just to show you what I'm talking about, 62.138 times 0.968 raised to the 6th power, that's 51. 7 years old, 49.4. So someone between 6 and 7 years old is responsible, and then you can start going back and forth to find the most accurate answer. 6.25, 6.5, 6.68 is what I came up with. Yeah, 6.68 takes us right to that 50% mark. So you could have just picked an age and started going from there. Part D wants to know what percent a 90-year-old is responsible for. So again, if Y equals 62.138 times 0.968 to the X, age is X, to the 90th, you end up with 3.328%. Okay, so it's just a matter of once you find out what it is you're looking for, substituting and solving as appropriate. The log stuff over here, it is a bit much, depending upon how much math you've taken before, because you're supposed to have taken Algebra 2. To do this using logs is something you're supposed to be familiar with. If not, email me. We can talk during office hours and get you set up with that. Also, the Math Lab is another opportunity as well. Continuing on in this packet, next page, talk about quadratic regression. So here we're going to compare an exponential and a quadratic regression. All right. So again, go through. So what we're looking at here. Table shows the population of Springfield in thousands of people since 2000 when t equals 0. Use this data to answer the questions below. So pause the video now. Well, not now. Pause it when I'm done talking. So what I want you to do is to work these out. Pause the video, work these out. And then come back and compare your answers to my answers and just see how you did. This is kind of like the closest we can get to like an in-class practice type of deal. All right. So pause it now and give it a shot. All right, we're back now. So for part A, the exponential regression, you should have had y equals 3.001 times 1.221 to the x value. Your r value should have been a whole bunch of 9s. R squared, again, a whole bunch of 9s. Then when you look at B, the quadratic regression, y should have equaled 0.323 x squared minus 1.310x plus 5.006. Your R squared value would have been 0.9905. Between the two of these, the exponential should have been your winner because those R values, I don't know how much closer you can get to being 1 without actually being 1. All right, so that's your answer to part C. The exponential is more appropriate because it has the better R values. Now, for part D, you would plug in for x. So for 2009, x would equal 9. Plug that in, you're going to get y equals 18.101. For 2020, your x value would be 20, and you end up with a y value of 162.772. All right? So that takes care of that one. So there's that. For this one here, the one above it, the best fit for this is a quadratic regression. Give it a shot. See how it goes. If you're satisfied with your work, great. Move on and try the homework. If you're not satisfied with your work, shoot me an email, contact me, go to the math lab, one of those, and we can talk about it, all right? Otherwise, your homework is attached to this packet. Do these on a separate sheet of paper and then submit them through Brightspace, please. Okay? That takes care of regression modeling and Module 3. Thank you.